Okay, continuing on. So this is where they start this piecewise functions, and I think the last ones are all this piecewise stuff. So if f of x is defined as follows, find a f of negative 4, b f of 0, and c f of 3. So f of negative 4. So I'm going to write that over here. I'm not going to write everything out because I suck at writing with this, but I still want y'all to be able to see this stuff. So what they're saying right here is x equals negative 4. So when x is negative 4, I got to figure out where that falls into this piecewise function. So all of this is what f of x equals. We have x squared negative 2, 2x plus 2. And that's kind of, I like to compare this to the key on a graph. Like blue is this, green means this, If we have a triangle, this is what that means. So they gave us negative 4. We figured out using our key which one we use. So negative 4 is not 0, negative 4 is not greater than 0, negative 4 is less than 0. So we're going to use x squared. So on this one, we're going to have to use equals x squared, where our x is negative 4. So we're going to have negative 4 squared. And negative 4 squared, negative times a negative is a positive. 4 times 4 would give us 16. So we use our key as if it was just one of these, and then we go from there. It's really weird when you first start doing it, but use your key to determine which function part you're going to use, and then plug that value into the part you have to use. So this one, f of 0, so since we have f of 0, that means x equals 0. And they tell us when x equals 0, f of x equals negative 2. So there's nowhere to put 0 in because there's not an x here, so we're just going to use this negative 2. Okay, and then our last one is f of 3. I bet you can't guess which one we're going to use on this. So that means x equals 3. Oh. So when x equals 3, that's greater than 0, so we're going to use f of x equals 2x plus 2. And we're going to substitute our x in here, so we're going to have 2 times 3 plus 2, so we'd have 6 plus 2, which is going to leave us with 8. Go back to that real quick. So we take what they give us as our x value, and they're going to give it to us in function notation, figure out which key part that falls under. So this one was our less than 0. This one was equal to 0, and this one was greater than 0. And then we take the part of the function that represents that x value and plug our x value into it to determine our y value. Piecewise functions are fun. Okay, so we have f of 0, f of 1, f of 3, and f of 6. And I'm going to talk about the domain as well on this one. So if we're looking at this one, how they gave it to you, if they ask for domain, and I think they do in the next problem or so, This one has restrictions. So our lowest x value they give us is -3, and our highest x value is 6. So the domain of this piecewise function would be -3 to 6. And since it has the equal to with it, in interval notation, this would be bracket -3, comma 6 bracket, if they asked for domain. Okay, so f of 0, we're looking at this. This means x equals 0. So which one does 0 fall under? -3 is less than or equal to x, which is less than or equal to 3, or 3 is between, or x is between 3 and 6. So we're going to use the top one, because 0 is between -3 and 3. Why is this so hard? Okay, and then we'd substitute 0 in for x. So 3 times 0, subtract 5. 3 times 0 is 0. Subtract 5 would give us -5. Oh, it's awful. Okay, and then let's do b. I can't even draw a straight line now. So if we have f of 1, I know we're going to graph in a minute, otherwise I'd just do this on paper. So we'd have x equals 1. 1 is between -3 and 3 using our key, so we'd have the same one we used in the last step. So we'd have 3 times 1 now, because we substitute this value into it. Subtract 5, which would give us 3. Subtract 5, so our answer would be -2. All right, 3. This one is one of them where you have to pay attention to your signs, because if we look at our two keys, they both have 3 in them, but one of them has the equal to 3 and one of them does not. So looking at this right here, this one is just x is greater than 3. This one is x is less than or equal to 3. So this 3 would actually fall in the top one because of that equal sign. Since that equal sign is there, we're going to use the same one we've been using. And then we're going to substitute our x in there. So we're going to have 3 times 3, subtract 5. 3 times 3 is 9. Whoop. Subtract 5. 9 subtract 5 would give us 4. Okay, can I don't know if it's going to let me go down farther or not. Did it? Okay. I guess I'm going to clear this then. Our last one is f of 6. What have I done? So since it's f of 6, if we look over here, 6 is our highest value. It's equal to it right there. So we're going to use this first one, and I'm going to go ahead and write x equals 6 right here. How do I make that go back in? Oh, I don't want to. Oh well. So we have f of x equals x cubed subtract 3. So we substitute our x in, so we'd have 6 cubed subtract 3. 6 times 6 is 36 times 6, I believe, is 216. We can check it. 6 to the third power is 216, so we're going to have 216 subtract 3 to get 213. Here. Find the domain of the function, locate any intercepts, graph the function. Based on the graph, find the range. So our domain on this one, domain is x. Remember that, domain is x. And range equals y, although, oh, they do ask about the range later on. So on this one, if we're looking at our domain, we have x equals 0 and x cannot equal 0. That's all it tells us. We know when it cannot equal 0, there is a value for it to be 0. So on this one, they've left us with nothing that couldn't be included. So it would be negative infinity to infinity. Because the only thing they say it cannot be, they also tell us what it is when it is that value. So everything else is covered. Locate any intercepts. So when we put 0 in, what would it be? And they want us to write this as an ordered pair. So let's go ahead and say I don't have a clue what I'm doing on this whiteboard thing, and it's driving me insane. Oh, so when we have x equals 0, that one's the easy one because we can go look. When x is 0, f of x equals 3. So that would mean y equals 3. So that would be one of our intercepts. I wrote that backwards. X is, why am I losing it? X is 0. Y was 3. Oh, the hard one. So we need to figure out when y is 0, what is x? So if we say y equals 0, that means we're saying f of x equals 0. So we're going to plug in 0. I'm going to write it under our function. Which one could possibly be it? So we're going to have 0 equals 4x and 0 equals 3, because we're, instead of f of x, we're putting 0 in here. We know 0 does not equal 3, so we can get rid of that one. This one, if we solved it for x divided by 4, we'd have 0 equals x. Now here's the tricky part. We already know what 0 is when x equals 0, or we already know the intercept when x equals 0, because when x equals 0, it's 3. So 0, 0 cannot be an intercept because when x equals 0, it's 3, because that piecewise rule. And since we already figured it out, our only intercept is this one. But now here is where that 0, 0 will come in handy, because if we were to draw this graph, we should go through that point 0, 0. And honestly, they all do. 0, 0, 0, 0, 0, 0. So the only thing we have to do is find this intercept 0, 3. This is at 3, 0. This is at 0, 3. This one's at 0, 3. Oh, I'm glad I got my glasses on. So these are both at 0, 3. We'll have to look at that. And that one's at 3, 0. So on these, that means these graphs are different. So since we have 4x, let's go ahead and put in a value to check. So let's say we have x equals 1. So we're going to have 4 times 1, which would give us 4. So let's find the graph that has that 0.14. This one at 1, we have the value 3, so this one would be the graph of 3x. This one, if we have 1, we would have that 0.4. So we have that 0.14 on this one, so this one would be our graph. Anyway, range is y. We talked about that already. So when we're looking at our range values on this one, we're looking bottom to top. This is our graph. So if we're looking for range, we have range values all through here. And it goes off the bottom of the graph, so we're saying it starts at negative infinity. But right here at this point, we do not have a value. But then it picks back up and it goes all the way up to positive infinity. So we have right here that it goes to 0, it just does not equal 0. We have everything that's infinitely close to 0, but we do not actually have 0. So let's see, the range consists exclusively or one or more isolated values. Isolated values would be if we just had this point, or if we had a line, a constant line at 3. We don't have an isolated value, but we do have intervals. So it does not have any isolated values. So we go from negative infinity to 0, but we do not equal 0, so it's a parenthesis union with 0 to positive infinity. And this is all because it doesn't equal 0, and at 0 there's not a point there. If we had a point at 0, or it wasn't this open dot, it'd just be negative infinity to infinity, but we do not have that. Okay, one more. Okay, so find the domain of the function, locate any intercepts, graph the function. Based on the graph, find the range. Domain. Domain is x values. So if we're looking right here at our x values, we have less than 0, and then we have greater than or equal to 0. So it's equal to 0 in there. We have 0 included. It doesn't say we're excluding anything. It doesn't stop anywhere like this one. If we had this one and they asked for domain, it'd be -3 to 6 because it's restricted. Ours is not restricted. The only value they talk about is 0, and it has an equal to with that 0. So it's going to be negative infinity to infinity. intercepts. Start with the easy one. So when we have x equals 0, we can look right here. This one has the equal to sign, so we would be using that function f of x equals x squared. So then we'd substitute our 0 in, so we would have 0 squared equals 0. So that means one of our intercepts, our x value is 0, our y value is also 0. So the origin is going to be one of our intercepts. Now the fun one, when y equals 0, y equals 0, which is f of x equals 0. So we have 0 equals 2 plus 2x, and 0 equals x squared. All right, here we know anything. I'm not going to assume we know anything. So we're going to solve this. So if we were to solve this, we'd have the square root of 0. And I'm doing this one first because it's easier. And the square root of x squared. So we'd have 0 equals x. It's the same as this one, so we already know that this point is 1, but that's what we solved for here. So we had y and x is 0. All right, let's determine if this is going to be one of our points. So we'd solve for x. So the first thing we do on this is subtract 2. Negative 2 equals 2x. Divide by 2. I wish it would have been an easier number to write. So negative 2 divided by 2 would give us negative 1. 2 divided by 2 would be 1, and we don't have to write that 1, so we'd have negative 1 equals x. Then we have to check and make sure it falls under our parameters, the rules that are set. So when x equals negative 1, would we use this function? So when it's negative 1, this is the function. And x would have to be less than 0. So since it's negative 1, I'm pointing at it like you can see me pointing. Since x is negative 1, it is less than 0, so this would be an intercept. So we'd have that intercept x value first, negative 1, and our y value is 0. So our only intercepts, these are the same, so we only write it once, is 0, 0, and negative 1, 0. Now, when we graph this function, first thing you look for those intercepts. So we have the point 0, 0. Check, 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 and check. Negative 1, 0. This one does not have negative 1, 0. This one does, so let's bring it up. This one does not have negative 1, 0. This one does. This one, it doesn't cross right there at that negative 1, 0 where it should. Okay. We can count back to our domain on this one now. Ours is negative infinity to infinity. There was no disjoint, nothing that happened, because we could say it's negative infinity to infinity. If we looked at this one's domain, there's nothing going on right here. If there's nothing going on right here, our domain wouldn't be negative infinity to infinity. It would have been negative infinity to negative 1, and then 0 to infinity. Since it does go on, this would be our graph, because we don't have a disjoint in our domain. Then if we would have solved this one to find our y-intercept, we would have known our y-intercept is positive 2. we didn't need to do that. Okay. So our range on this graph, let's pull it up. Looking from bottom to top. From the bottom, we have values already, so we know we're coming from negative infinity. As we come up, right here we have double for range, but there's nowhere that there's not a range value, because right here they join together. And when I say join together, I mean like if we were to flatten this graph together, there would still be a range value at both things, even though they overlap a little bit. So this graph doesn't, how do I want to say it? It has a range value everywhere, because if we were right here at -5, we have a value. -4, we have a value. -3, we have a value. -2, we have a value. -1, we have a value. At 0, we have 2 values. At 1, we have 2 values. At 2, we have 2 values. 3, we have a value. 4, we have a value. Right here where this open dot is, we still have that range value. So our range is going to be negative infinity to infinity. Okay. I think that one's, the piecewise part is probably the most confusing stuff for this test in my mind, but I like the other stuff too, so I'll let y'all decide for that. Send me questions if you have them so I can try and clarify, because I know this is difficult to learn online already, so if y'all need help, let me know so that I can help, if that makes sense. I'm going to stop this one.